So good evening all. Sorry about that. Yeah, so today is still QA and more software manual testing. I'm still the same person, Yemi Ayola. I welcome you all to the class today. And predominantly today will be these our activities and topics for today. Today we'll be talking about what Sdlc is, what Stlc is, the difference between both of them, defect life cycle, and the final part of it will be Q&A. And just a quick reminder, just my expectation in the class, try and listen carefully. If you can't hear me, please send it in the chat and let me know. I'll try my best to be kind of quite audible. And also pay attention because there are a lot of things going on within this part. A lot of information, a lot of terminologies will be used in this session. So I expect you to just keep calm, listen, and at the end of the class, you've got your time to ask your question, and I will also ask my question. So yeah, let's start the class. So I would start with the Sdlc acronym. We've been hearing the word Sdlc, Sdlc, Sdlc. What does this stand for? Sdlc it stands for Software Development Life Cycle. Software Development Life Cycle. All that word, Sdlc. So when it comes to the whole development team as a whole, when you hear the word Sdlc, know that they are talking about software development life cycle. Also, it is called software development process. Some people call it that. It's a framework that is used in designing tasks performed at each step of the software development process. We're still going to dig down and talk more about it. But just have it at the back of your mind. The acronym is Software Development Life Cycle. So before I move further, I just want to talk about what is this software development life cycle. Life cycle. You know like literally the meaning of life cycle. I'm still going to explain more about it. So what is Sdlc or the software development life cycle? Is a process that produces software within highest quality and low cost in the shortest time period possible. So what they are trying to say is that Sdlc is more of a process. You will be able to, there are projects that are being done, but the quicker we are doing it, the better for everyone, for the business, for the client, and you are getting new people coming in. So that's why but you are giving them the high quality. Hence, because of this Sdlc, there are some methodologies, some ways that were derived because of this to make things easier for people to have good quality of the product they've actually asked for and at a lower cost. That's the essence of software development life cycle. So before I continue, I want to take this out to a normal world where let's understand literally a layman what a life cycle is. What's a life cycle? I took an example of a chicken. It's a life cycle. Let's start from there. So it starts from here. There is an egg. After the egg, we know chicken. We know from there, this egg wants to turn to be a big one. In the egg, you've got the embryo, which is more of this person trying to hatch, trying to form something. Then the next thing is we've got the hatchling. I've broken up. I'm trying to come up. Don't forget, we started from egg. We can't see anything here. Now we are the egg is trying to form itself to the embryo. Now it's hatching, then we've got the chick. Then this turns to be the big person. The main thing that we want to see is this adulthood. That's the chicken. That's the life cycle of the chicken. Now take it again to our normal human world. You and I was conceived 9 months, delivered. Within that 9 months, I was somewhere around here in this place. After 9 months, I was given birth. 10, 20. Now I'm an adult. That's the end product. Now I'll take it back to software life cycle. Software development life cycle. That's it. Software development life cycle refers to a methodology which clearly defines process for creating high quality software. In detail, this software development life cycle focuses on the following phases. So it's just for the essence of software development life cycle is just to create good quality software for all their clients on the project you're working on that. And hence, you are also here, you're already in a team. You are going to use this process, this software development lifecycle process. That's what you're going to use within the team because you are working in an agile environment. So it's one of the process which is birthed by this software development lifecycle. Now, let's take it further. What are these phases that is required when it comes to software development lifecycle? One of them is the first stage is requirement analysis. Now, I want to take you back. Remember, in our last class, we talked about general principles of testing. We talk about fundamentals of testing. We talk about error, defect, and failure. Now, this is where we are actually going to. All those things we spoke about in the last class, you see them come to play in this process, this life cycle we are going to talk about, both life cycles. So the first one is requirement analysis. If you remember, requirement analysis, we gather the requirements, we all analyze the requirement, get an understanding, do a kickoff. The next thing is the planning phase. We have the planning phase. The third thing we have is the software design. That's we're talking about the architectural design. So this family, they are six, they work hand in hand. We talk about software development, talk about the design, the developers, and you and I. We talk about the big people there. We're talking about testing, and the most of it all is deployment. So it's a phase. This there are different things, is a process. One cannot leave one. So you have to gather requirements. You must know what you want to. You can't just get you must know what exactly the project is about. You must know what you want to build. You must know. So then we plan, we do the software design, we do the software development, we talk about testing, and we talk about deployment. These are the 6 phases when it comes to software development lifecycle, Sdlc. Now, I just took it as more of it for you to give you a clear view that now this guy, number one, will start requirement analysis. It will move up to design. So when the requirements are being gathered, everyone is aware, we start doing it. Then the design, we have a pictorial way. What is the big brain? What is going to happen? Then from 2, it goes to deployment. Then these guys start coding. When they start coding, then they will do, oh yes. Then After the coding, it forms testing. After testing, then we do the maintenance in terms of deployment process, support to the client. This is mainly the life cycle of software development. That's the way the life cycle is. That's the way they grow. The deployment is the main person. That's the end product. Deployment is when you have deployed into the user's environment. So I'm just going to take everything one at a time, just to give you a clearer view, and until we get to the exact point where we are going to in this. So with Sdlc, I'll take the first one as requirement gathering. So let's say requirement gathering and analysis. So in this place, the back and forth of requirement is you want to understand what exactly the customer wants, what the client wants. So we gather requirements, you look at different informations. There are different stages. You as a tester will be asking, and also the developers. Don't forget, there's someone that has the bigger brain in terms of requirement gathering, and that could be a business analyst. In a place where maybe there are no requirements, we are going to come back to that, how you are going to gather requirements as a tester. That is another phase. But a requirement gathering is gathered by the business analyst. Then you as tester, you read the requirement, you check it. Do I understand what exactly it is? Where is the bigger picture? What is the end product? What are we going to design? Do I have a question? So your questions can be asked at that phase. At that stage, you can ask any question to know that, yes, this is it. Then the next thing we go into for is we call the planning and design. If you're going with me, if you remember some of our processes when we were doing fundamental principles, that has to do with planning, test planning and control, test analysis and design, fundamentals. Those are the fundamental principles. So, but we will get to that side. This is planning and design. Now you are planning. We as a project team, we as development team, we are all, the project has been set. We want to develop project A. You have been divided into various groups. This is what they want to achieve in the group. And in the group, this is what the project is going to be about. And once we want to do that, then there are those requirements that have been gathered. We need to now start looking at how to start designing those requirements. Yes, they have said is a chicken that we want. We need to start from the smallest part, which is the egg. So we've gotten the egg. Now, after the egg, we need to start doing it so that the egg can hatch. When the egg hatches, then it moves. Then it becomes a big adult. And that is where exactly we are going to bring it back to our own world. At this phase, what we are actually doing is that we also are planning as a team. This is the project that is going to be delivered. So several of us as a project team, we come together to say, this is how it is. And the plan and design, this is the planning and design phase. It takes quite some people, some expertise in this. We are talking about the architects will be involved. You as a tester, talk about the business analyst. They need to give us the bigger brain about things, and for us to know the major things you are going to do, the layout, how the project is going to go. Then the third part of it is when we talk about building it. How do we build? What is this all about? You see, we are still not deviating from what we were learning previously. This is a big format, but it's more like in a granular way now, breaking things down so that you know that each of the phases really matters when it comes to software development lifecycle. If there are no requirements, it means there are no projects. That is what it means, literally. If there are no planning and design, then we don't have a headway. Then the third thing is that we need to start building. What do we want to build? We were talking about the code sets. This is going to be done. It can be done by a developer. It depends on how complex and big the project is, what the scope of work is. That is what it determines. So then once the developers, they've started doing the code, this is the building phase. We all now, they are doing it. You as a tester, you can be involved in peer reviewing, looking at what was structured. All those phases can be done after the building phase. Now we're talking about testing. Testing. You can say that there's no how. You as a tester, you are actually relevant in every phase when it comes to when it comes to IT world, when it comes to generally, testers are always needed. Testers are always needed. So now we know that the codes have been built. It has been written. Now the time to test has come. So this time is for you as a tester. Your major thing as a tester is to find the bug, break the system. Let's find as many errors as possible. Let's look for a lot of defects at that phase. That is when we know that, yes, once these defects are fixed, there are processes. So immediately those defects are fixed, then we got and we are all happy with the system or the defect. Everything have been triaged, fixed, retested, and regression sets have been done. Then there's a deployment phase. At this phase now, that is when we know that all the errors that we have, it has been tested. Now we need to now send it to the business users, to the people that actually need the people that are going to use the application. That's to the production environment. And this is always mainly in the business side, maybe for people to test, have another eye, look at it, check it. Then the last of it all will now be the maintenance process. So we need to know how these are going to be maintained, what are the stages, how everything. So these are the 6 phases that I want you to have that we do. Remember, there are 6 phases that goes on when it comes to Sdlc. Sdlc, software development life cycle. It's just a life cycle. The end product is what we are all working towards. That is our goal as a team, as when I've been talking about team, I talk about including you as a QA tester, including the developers, including the project managers, the scrum master, business analyst, product owner, and architects, solution architect, data analyst. All are part of this team, this wider team, to achieve it. So now at this phase, I'll now go to another format. I've been talking about software life cycle, software development life cycle. I want our learning objectives at this point is now that we want to deep down and also drive down to see what exactly are the methodologies behind this. What are the things? What are the areas? How is software development life cycle in place in testing? What is our role as testers there? What is this? That is where we are actually going. So in this phase, I'll be talking about the software development lifecycle, the different models, the models of Sdlc, the advantages and disadvantages are the pros and the cons, and the concept of understanding. So all this will be what I'll be talking about in this phase. So let's take example, software development lifecycle. It's also called the iterative and incremental development model. We have several of them, several. So we are talking about the rational unified process, spiral. We've got the V model, we've got the Scrum, we've got Kanban. Not to forget, we've got waterfall, we've got we've got waterfall, we've got V model, and last of it all, we've got an agile. So major one that I want us to talk about are these 3. These 3 are what we actually use currently. And there's a big one that is there that everybody is adopting now. All organization, everyone, that is what everyone is tending towards to now. We've got waterfall, which is more of the linear model. We've got the V model, that's the sequential development model. Then we've got the iterative one, which is more of agile. That's the big guy. This guy is a big one. Everyone is using him now. And all organization, most people, even if they're not using it fully, they are adopting some parts of agile. So I can tell you, when you are even looking for a job, they will tell you, have you worked in an agile environment? I've said it, agile environment. Yes, I have worked in agile, because while you are going to be on this training, you are going to work in an agile environment. You will have a full understanding of the process of agile. So before I go further to agile, I want us to take these two and move down to that. Now, waterfall, V model, and agile. And the reason you can see agile is called iterative incremental development model. The waterfall, you will see the reason. So I'll take the first one, which is waterfall model. In this model, I want us to see this picture in this model. In this model, this picture looks like this. It's called waterfall. So the reason for this is, you can see that it's just like water is falling down. That's the reason, hence the name of this model. Look at the 6 phases here again, coming to play. Requirement, design, development, testing, deployment, maintenance. We are still on the same 6 parts, but just the model, the process is now different. So at this phase, for waterfall, the way it works predominantly is that for waterfall, you get requirement. The next thing, you get the design, you get development, testing, and deployment. So how this works, let's come to it. The first thing you get is requirements. All the requirements are being gathered. None of us is involved in requirement gathering when it comes to waterfall. If is the BA, product owner, whosoever needs to be there, we as development team, as in both the architect, every one of us are not in play. We are not even in the picture at that moment. So that is done by the business analyst major that's chairing that. So once the requirements are gathered, now maybe requirement gathering is a long time. He's going to speak to different stakeholders to bring things together. He or she gets that. After requirement is done, then we've got the next phase. Now, the requirement guy, which is the business analyst, will say, oh, I finished gathering the requirements. Now, design team, can you have it? You, the design guy. Now, we forward it to the design. Design too, we look at it. Okay, this is what I understand from what the requirement they've gathered. He was not in the picture. So he would design it according to his own understanding. No questions being asked. Now, after that is done, he also must have taken, let's say the requirement gathering took like at least maybe like another 3 months to do it. Let's say the design team too, they'll have to think about things, bring things together, use different tools to gather all the requirements to make it a document for us to be more readable and simplified for the wider team. Now, design will now do, he or she might take 3 or 4 months to do that. Once that is done, we are still not in the picture. Now it's passed to the developer. Now at that stage, development, which coding is implemented, you will start looking at the code. It might be in small, in components, in modules. So unit testing is in place. All that scenarios will be in development. That again can take another couple of months, which to deliver that. Now they'll bring it back. I, as a tester, am not involved at that stage now. So testing now starts. development is done, they send it down to tester. Tester will start testing. I don't know anything about it, so I just pick it and start testing. If I find bugs there, there's nothing I want to do at that time. I found the bugs. Nothing can be done. It can be fixed. We have to do the deployment like that. Once the deployment is done, it goes to maintenance. Then we send it to, have we delivered a good product? No. So if we find any issue at that stage, we will send it back to requirement. Then they'll do requirement gathering again, send it back to design, development, testing, deployment, and maintenance. That's the process of waterfall. Now, what is the advantage? The advantage is that if it is a small project or it's a project that you all are aware of, you know the nitty-gritty of the project, it's something that you have done before, you all have a clearer understanding of it, and it's a small project. If it's not a complex one, it's a good way, it's a good model that you can use. But if the disadvantage is that if you're using this as at any maybe complex project, if there is anything wrong at every level, maybe we now find a bug when it comes to testing. What happened is that we'll have to go back to requirement gathering phase. We will start all the way. This is a longer process, and it takes time for this process to work on. So at this phase is kind of an expensive model to use. So let's take it further to the V model. So V model, why is it called V model? I will tell you. Look at the picture here again. Look at the shape of this picture. It's a V, and that is the reason why it's called V model. Hence the birth of this name, V model. This is another interesting model. It's a very good one. Because at this V model, what happens in this stage is that every phase of verification, there is always a validation. What it means is that if the requirement is being gathered, testing is in place. So what happens is that once requirements are gathered, testing is in place for that stage, that phase. So as we are gathering requirements, we are also doing acceptance testing. What is it? You have said this is what is it. I don't understand it. Can you put an acceptance criteria? What is the meaning of it? So you are asking questions at every phase. There's every testing to validate each of the stages. So go to the next one. If it's a software application, you will get a system testing to validate it. If the design is coming, you'll get an integration testing to validate that. So at every phase, there is a testing activity. There is a test level assigned to each of these phases. That is exactly what V model does. Now, let's go further. Before I go further, I want you to note these two words: verification, validation. Please note those two words: verification, validation. So verification, validation, they always is an interview question, which is always asked all the time. So at the detailed requirements, you get an acceptance testing to get there. So all these are the way V-model application works. So I'll take you further to it to say, at this stage, let's take verification. Verify, English word, verify. I want to check whether what the product that we are testing, we are actually building the right thing. That is what verification means. It means that, are we actually building the right product? That is what verification means. What is validation? Validation now is, I am checking it now that this product, is it as expected what the client wants us to do? That is what verification is all about. So take it as expected and actual. Expected is verification. My actual is that I am validating it. That is what it means. So now, are you building the right product? Is this what the user, the client itself, is this what they want? That's what that phrase means. So what is the pros of this? Testing early in the life cycle, thereby enhancing the probability of building an error-free and good quality product. Reason is that at every phase, if you are doing the requirement, there is an acceptance testing going alongside with it. So it's easier for you to catch the bugs earlier. Hence, is a good way, is a good methodology. Now, what is the disadvantage? On V-model, if any changes happens in the middle, then the test document, doing the requirement document must be updated. So it's just like waterfall. So if at the middle or the design phase, you find an issue, we have to go and start from the beginning again. So from the beginning, we'll go to the requirement, do an acceptance testing, go back, we'll do that. So it takes longer. Hence, the disadvantage of this. So the last of it all is the iterative incremental development model, which is agile. This is a lovely, it's more of, it's a phase that most organization is easier. We are testing in bits. We are doing things in more of a quick format for the product to be done. So let's take an example. We want to actually build a big project. Let's take like Blue Sky is a log. For Blue Sky, when we wanted to start, you will have to register. So how do you register? Is a functionality. Is a functionality. It is something that is meant to be part of what you can register. If you're a new user, if you're an existing user, you can log in. So let's take registration as one of the things that we want to do. So if you register, you want to be able to access the application. So when it comes to this method, this model, what you do, what happens there is that, okay, this is what we want to do in this sprint. We want to actually work on registration. So we all start as a team. Registration, we gathered requirement for registration done by business analysts. We are all in loop. Okay, for the registration, how do you want it to be? Oh, this is it. Please, can you state it here? Write it in the requirement. I correct and I will check everything. Oh, I have a bigger picture. I start designing my own script to suit whatever I have in that requirement. While we are doing that, design phase is coming, which is more of prep in terms of architect, they will start looking at it. How is it going to link? Okay, registration, put the name and that. After that is done, we start coding. And once coding is done, it moves to testing. I'll start testing all the scripts that I have written previously. And once that is done, we put the software, we deploy it to the environment, we give it to the users, and they will test it. Oh, yes, fantastic. Login, this registration, the registration is working as expected. That is one phase. We keep that code. That is one iteration. We have finished that loop. Okay, the next one we want to take is login. We start the process again, requirement gathering, design, coding, testing software. That is a form. So it's in bits. The code, they are tested in bits until the final stage where we actually integrate everything together. Look at it. It started with the egg. It was nothing. We didn't see anything. So with the egg, we will test a bit. Just let's get the egg first. Let the egg be out. We know our endpoint. Now, everybody have gone through. We have gathered the requirement for the egg. So yes, at the end of it, this is the egg. We'll keep the egg. The next thing is the embryo. We want to see what is going on in the egg. We started getting the gathering the requirements, the design phase, coding and testing. That goes in. That's another phase. So once those are done, each of the ones that we are doing, they are called iteration. So for the first one, I have gone from requirement to design to coding, and once it's deployed, everyone is happy. All bugs are tested, and it's fine. That is one iteration. That is one loop. Take the next one, another feature you want to do. That's the way this works. So the next thing is what you were looking at it. What is the advantage? You too, the way I've been talking about it, think about it. We've quickly tested this. We are testing it in bits. So it's easier for you to get good deliverables. Everyone is happy. Everyone is in loop. The clients knows what you have what you have actually what the team has developed, what they have. So they have the registration. They know what is happening. Everyone will work together as a team. So there's always an end product. So that's the advantage of it. After then we do the requirements, everything. So is quick delivery to the market. The customers are happy. You as development team, you are happy. Everyone is happy. Then the thing that is that the disadvantage that we have here is that for agile, it requires planning. You must know how to plan in iterative method. If not, you don't want to bring what is not meant to be. Instead of people cannot register, people cannot log in. You want us to start doing how to launch the application. No, it can't work. So you must know how to plan. You must know what the priorities are. You must know what will come in. That's the job of the project manager and scrum master, and they will decide on what goes into the sprint. And we are as sprint members. So let's take it. Let me now take it to you in the picture for you to see. So let's take it. Number one, requirements, analysis, design, coding. That's one iteration. It's done. We take it forward again. We keep that. We start the second iteration. We do the same thing, requirements, analysis, coding, that. Until we get to where we see that the chicken has grown, is now an adult. That's the end product. That's the end of agile. So I just took this picture again to make us know how things are done, mainly from just the agile model for us to have a view of it. So at this stage, it's done. We start from the definition of ready. There's a backlog where all the things that we want to do, they are stored, they are there in the backlog. We as a team, we start putting them into sprint. So in this sprint, we said registration is what we want to do in sprint. Sprint mainly is meant to take 2 weekly. Some do 3 weekly or a month, but it shouldn't be more than that. Most of the time, happy part, 2 weekly, everyone is happy. So that's why you commit the little that you want to go into the sprint. From there, from the sprint, it goes into development. Developers pick this up. Once they are done with their bit, it moves to testing. So at this phase, you as a tester, you start testing. At that time, it moves to integration. It's still more of testing bits, linking what we have done together. If you follow the green part, it will go under and go to the deliverable. So the delivery will be to the client. And once everyone is happy, then raise it up, we are done. That's the way Agile works. Is a good way. We are testing in bits. Everyone is happy. You can deploy quickly. People are seeing what they are paying for because the people that are sponsoring the project want to see the output. This is what makes them happy. So when they see that you have done this, they don't want to know what is in the code set. They don't want to see what is behind. They want to see the final, the end product. That's what will make them happy. Now, at this phase, I took it again just for us to have a clearer view because this is exactly what you're going to be doing as that. Take requirements, design, testing, iteration, same loop. So that's what is in your first build. It will go second build until you get to the final, to the nth build. We are still talking about the iteration. Now, I will now take it further to say, so this is meant to be Stlc. So what is LTSC? The acronym for this is Software Testing Life Cycle. Look at me. This is meant to be Stlc. Stlc, Software Testing Life Cycle. We have just finished with software development life cycle. We need to come to us as a team. You as a tester, this is your own phase. This is your own work. Software testing life cycle is a sequence of different activities performed by the testing team. You can see now it's segregated. It is you as a person, you as a tester, you as a QA, to ensure that the quality of the software or the product, it is the right quality. That is what you are testing on. That is the process of software testing life cycle. So let's go further. What is the role of a software? What is our role as software testing life cycle? What is the major part you pay there? So we know we've got a lot of talented developers, but no one cannot make mistake. If you know, when we're talking about error, we spoke about people who can make examples of error, people who can make the errors. Now that boils down to who can make the error. It could be anybody. Hence, we are bringing it to our own self as testers. So your own role is to make sure that whatever is being developed by developer is tested properly. Mistakes happen. So we need to find this mistake earlier enough. Also, the role of software testing lifecycle is to identify any mistake that have been made and find solution for them, helping to maintain the quality of every piece of software produced and ensuring that the project requirements are met. So, as this is done, this is the major role of you as a software tester, as a QA tester. That is your role. So now, let's now go to Stlc phase. You know, we've talked about the phases, the 6 phases of Sdlc. Now let's take the 6 phases of Stlc. So the 6 phases of Stlc, now we are taking the phases of Stlc. The software testing life cycle contains of 6 main phases, each which involves specific actions designed to ensure that a high standard of performance and quality is achieved. So at this phase, these 6 are also going to be the phases that we're going to talk about, and I'm going to break them down. So the 6 phases are, we still go to the same way: requirement analysis, test planning, test case design, environment setup, test execution, finally, test cycle closure. If you look at all these processes, these 6 go back to fundamental test process: test planning and control, test analysis and design, test implementation and execution, evaluating exit criteria, and reporting. The last of it was test closure activity. Now, everything has come to play here again. So in everything we are saying still boils down to one thing, the same thing we are talking about. So this is all about the 6 phases of software testing life cycle. We have 6 for software development life cycle. We also have 6 for Stlc. Now, the 6 phases are different because it's now streamlined to testing. Let's start. So I just put this for you to know how it revolves. So we start with requirement gathering. This is the person that starts, number 1. From purple, you go to this place, which is more test plan. We go to the test design. We go to the environment setup. We go to the test execution. We go to the test closure. That is the way the cycle is. I took this to say you have started with the egg hatching. From the egg, you are hatching. So, I mean, there's the embryo, is the planning phase. Okay, how is the baby going to look like? How is this chicken going to come out? How is this going to form? So we are looking at, what color is it going to bring? Is it going to be yellow, black, white? We don't know. So this design is a phase. Then this environment, at what stage, where is it going to, inside which, is it going to act from where? Inside the shell. Then there's an execution. We need to see, it's come out now. It's come out. It's done the big thing. We have seen it. Now we need to let people know that we are finished. That's where the closure comes. So that is software testing life cycle. Now bring it back to us. Planning, requirement analysis, test planning, test design, environment setup. So let's deep down into it. I'll take the first one, requirement analysis. As we've been saying, requirement analysis this phase. As a QA, your own is to validate, read through the requirement document, do more of a static testing. How is static testing performed on a requirement or a user story? In a user story, which is more like we've got requirements, we've got user stories, they're all forms of specification where requirements are gathered. So you get a user story. In the story, they've said as a user, this is as a user. So we know is a user that is going to use that is the actor. The actor there is the user. So that's the person that is going to use this. As a user, I want to be able to register on Blue Sky. That's what you want to do. So as a user, if I log into Blue Sky Citadel.com, I want to be able to register on Blue Sky. That's what you want to do. Now, that is the big story. That is the user story you want to do. You as a tester, you now need to think, as a user, okay, as me as a user that I'm going to use it, what are my expectations? If you don't even know anything, remember there's different registration you would have done. When you wanted to create a Yahoo account, you did registration. If you want to do go to school, you do a registration. So there are various forms of registration. Now, your question to them is that, can you break down the registration? How do you want the registration page to be? You as a tester, you don't want things. You know the hassle of things when things are not user friendly. So you want to think, okay, what do you want there? Name, first name. Do you want middle name? Okay, yes, you can put middle name. It could be optional. Do you want date of birth? Is it day only or you want it with the year? So you just ask those questions. These are way to know. Anything that they want there, let them ask those questions at that time. So this might require the team to communicate with stakeholders, fantastic, to understand the requirement in further details. So there are many ways we can actually do in terms of you asking question, knowing, getting more view about what the requirement is all about. Then the next thing, let's talk about activities of requirement analysis. What are the activities? One, they identify the types of tests to be performed and assigned to the development. So you as a tester, at that phase, you already know that, okay, this is what type of test are we going to do here? You start thinking. That is the phase that you need to start thinking. This is what we are going to do. The next thing is you will gather details about the testing priorities and focus. Don't forget, we had several questions in the last class about how priorities are set. So this is one of you when you are doing the activities in your requirement analysis. So you as a tester, because you as a tester you also have a part in analyzing the requirements. So prepare the requirement traceability matrix. We call it more of a RTM. We call it TTRM. So when you know requirement traceability matrix, what does this mean? You've got a matrix. We have got registration was what we were using as our example. So I want to register on Blue Sky. In registration, that is a functionality that you want to test. So what you are going to do is that you take that registration as a whole. In the requirement, take it, bring registration out. How many test cases did you write under registration? Map it to it. So we have 21 test cases. We have 2 test cases attached to registration. If login is the next phase, we have 24 test cases attached to login. What it gives people, what it gives you is that every requirement has a test case attached to it. So which means you as a tester, you have validated all the requirements as expected. That is what it means. So you are tracing it back to it. Trace. So I'm tracing it back. Okay, for this is what I've gathered. That is the activity as you as a tester will do when it comes to requirement gathering, requirement analysis. Identify the test environment details where testing is supposed to be carried out. So at this phase, read the registration page. Okay, where do you want this to be carried out? You need to ask the question. Is it in all phases that you want the because some might say we don't need registration in the test place. We need it in UAT. We need it in life environment. So you need to identify the details of which environment we want to actually carry out that requirement. Then the next thing, If needed, if you need automation for this, for any part of the test theory, you need to conduct the feasibility of the automation. So, and you're already in the class where you're going to be taught how to do that part. So that is, if it is needed, you will know. So that's the activity. Now there's another phase I want us to, deliverables of requirement analysis. What are the deliverables? ROTM is the document I've talked about, mapping that. So the next thing is automation visibility. At this phase, you want to give a report. What is the report about? How many test cases? What are the analysis of the results? How many of them passed? How many of them failed? Don't forget, I've told you, if you have written 100 test cases, don't say 50 test cases passed. No, 60 test cases passed. We don't want to know how many test cases you've written. The business doesn't want to know. Talk about in percentage. When you're doing normal statistics, people don't want to know 200 million, 500 million. We want to know what exactly the percentages are. Oh, 60% of the tests passed, 20 were not run due to this, 10 of them were blocked because of this environment, because of this issue. So you're just analyzing in bits that way. Give people clearer picture and understanding of what is actually going on in the report. You will be taught how to do that too. So let's go to the next person, which is test planning. Test planning. Test planning. What is test planning? There's a phase for it. We have talked about test planning. This is more of documentation. You giving documents of test plan and test strategy. You are going to have a template. You are going to write your own test plan and test strategy here. So it's just for you to have a blueprint. I explained this too in the last class when it comes to test planning. We want to start a project. We need a bigger picture. We need the person to tell us what it is. So we need to plan ahead. What is the document we need to prepare? This document needs to give an overview of what is going to be tested. The testing approach, what is the scope, what are the features to be tested, features not to be tested, what are the responsibility, the rules. Now, the test strategy is more of a breakdown. This is the type of testing we are going to do. We are going to carry out regression testing, retesting of bug fixes. These are our exit entry criteria. All these have to be in detail stated there. There are a lot of templates of test plan, test strategy all over. Yours is to find an understanding of what the project you're talking about and adopt it or use it to test plan. You will be taught how to write that in the next class. The next thing, what are the activities in test planning? The first activity is preparation of your test plan and strategy document. The second thing is selecting any tools required during testing. Now, after we prepare, in this phase, in this internship, you are going to use Azure DevOps for most of your tooling. When I mean bug raising, we are talking about your test case designing, creating test suite. You are for your automation, you are going to use Selenium WebDriver, you are going to use Visual Studio. All these are tools that you're going to use. So you also need to plan for them. If it's going to be paid for, if you need licenses, all this needs to be in part of what are the activities when you are planning. Also talk about test effort estimation. What are the effort estimation? We need to imbibe these two also when it comes to planning. Likewise, do we need any training? Is any training required? Does Yemi understands the application? Do we need to train her? All those you have to put in place. So if you need to train, all these are part of the things you think of when you are doing the planning. So the next phase is that what are the deliverables of test planning? The first deliverable is you provide a test plan document. You as a QA year, our expectation at the end of internship is that you must be ISTQB certified. You must be ICEP certified. So in that, you have a soft copy of the textbook that we have sent to you, the one we use. In there is a phase, is a plan. Okay, test is a plan So you've got a test plan document where you can read, look at the approach. So what are the things in the test plan? Scope, approach, resources, and schedule. So these are the things that are expected in your test plan. Now, the test effort estimation document. This document, it includes the estimation of how long it will take to complete the testing tasks. So like now, when we were looking at it, the whole thing, how long is it going to take you? You have to estimate it also. If you are picking a user story that has been developed by a developer, that the developer finished and is being sent, pushed to test environment, it depends on how complex that task is. If it's a complex task, if you've got various scenarios that you want to work on, you have to estimate towards it. Don't just feel that, when I mean estimate, it doesn't mean that you should, for a tax, you should tell them you are going to use 1 month to test one tax. Which day are we going to finish the whole testing? If you use 1 month to test one tax, it won't be delivered. So we have to use hours, days to verify what we are testing. Is a tax. So we can say, oh, with a couple of days, 2, 3, 4 days, I will be able to finish this task because I've got various scenarios that I want to. If it's something that is just for you to see how it's looking, then there's a way you can task. Oh, a day or two is fine by me. The day that you're spending, maybe it's an hour or 2 hours you're meant to, but you've also bought time for yourself. So all that too is in place. That is deliverable. So let's go to the third one, which is test case development. This is you as a tester. This is your job, I tell you. So this is the main job of a tester, test case development. Interesting part. You are going to be taught in the next class. This is what I'm going to talk about. Test case development, how to design your test case manually. You will also be taught automatedly. But for in this class, you are going to talk about manual test case design. If you beat this manual test case design, forget it. Automation this is the beginning of it. Your foundation lies in this. You as a tester, you as a software tester, a manual tester, UAT tester, this is your job. Bug finding, test case design, script design, all these are it. So test case development. So at this phase, we are talking of how to design our test case, creation of it. I don't like the word creation. I told you I use design so that it's kind of interesting, so that people will know that yes, this person is this is a job. This is what you do. So instead of creation, no, I'm going to design my test case. Design means I am going to create. I am going to write. I am going to type my test case. That is what it means. But I'm just using it in a more good terminology that people will know that, yes, you actually know what you're doing. That's why I use the word design. Design my test case. When I talk about design test plan, you are also writing it. You are going to type it like the normal typing. So that is the way things are done. So you will do your test cases, all the edge cases that you want to test, all those will be done. So your validation, your verification process, that's your actual and expected results are expected to be in your script. All these are part of the things that will be there. So let's take the activities of test case development. So the first activity, preparing the test cases and any automation script if required. The test case we're talking about here is the manual test case. So in my next class, I expect you to come in here with your Excel. That's a spreadsheet. Just your Excel sheet is what you need. You don't need anything. And for you to be able to type in it, that's the only thing you need when you want to do your manual script. Then the next thing is looking at all the actions, enumerating the possible actions of the users and their objectives. That's more of stating all the steps, the conditions, what your expectations are. That's what you want to pour out into the script. The next thing is setting the priorities of the test conditions. Your test condition. What are your test conditions? Registration is a test condition. The step you use in doing the registration are more of the delivery, just a forward step, step by step act. Then the next thing is selecting the condition under which testing will take place. How is it going to take place? How am I going to test this? We are testing it manually. This is how we are going to execute it. So all these have to be in place. Documenting any test condition. So all these are the test cases script, your script at large. Verifying and correcting the test cases based on the modification. Now, this one, I want to explain it so that you can get an understanding. I've been talking about requirements. I've been talking about a lot of phases that we need to understand. But when you're designing test cases, don't expect that you have a screen in front of you. No. Your test case design is what you find in the requirement. That's what you use in designing your script. So you are going to design your script according to what is in the requirement, what you understand in the design document. Now, when you are testing, doing the real testing, you can now be updating. Maybe now you thought that first name will be there, last name will be there, middle name. Maybe at this time, they've changed it. We don't want middle name. No, let's waste the space. Take middle name out. Just first name and last name. They can write as many names in the first name, but last name should be one. That is something that you in your own script, you already said middle name should be there. So you just need to update it to the actual thing you're saying. So you can be modifying your test cases, or even if you don't see the screen, if they said, oh, Yemi, requirement has been updated, we need to remove middle name. You to go back to your test cases, every places where you have put middle name, remove it from it. So that's the way it works. So now let's look at the deliverables of test case design. Your first deliverable is to do your set of actions. What are the actions? What are the functionalities? What are the test cases you want to work on? Build them on. The next things are the test data. What do we mean by test data? Test data are things that you want to use, the content that you want to use to test. Like in our general principles of testing, the 7 general principles, we said testing is content dependent. So you have to have something that you're going to use to test. If you just go to www and you click on registration, you don't do anything, you don't type your name, and you just click submit, nothing will happen. You can't register, it will bring up error. So you have to put some test data. What are the test data? In the registration, they say, what's first name? Yemi. That's the test data. Last name? Yemi. That's the test data. What's the date? What's this? What's the course? Software testing. That's the course I want to do. So those are test data that you're collating. The inputs, what you are going to input into those things are your test data. The next thing is that we talk about test automation scripts. I'm putting this for you to know things work hand in hand. We are going somewhere. So, but the major thing here is if you've got a automation script, you need to also bring up the automation script. Likewise, there's automation test strategy. So it depends on what you're doing. So that's it when it comes to test case design. Let's go to the fourth one, which is test environment setup. Test environment. We have been talking about the test cases. We've been talking about planning. We've been talking about, there is somewhere that we have to put this. What is test environment? Now, look at the blue sky. You were given a link. When you click on that link, it takes you to a URL. Naturally, if you are working on a project, you'll be given an endpoint. Endpoint is URL, www. The project name or whatever name they are put, and they log in, it's an environment. You will see that is not live. It is the environment that just you as tester, you within your development team can view. It's not to the outside world, but we are testing towards to take it to the outside world. So that's why test environment setup is kind of key. It consists of elements that support test execution. The setup of test environment is done based on the hardware and software requirement list. So there will be, the test environment will be done based on some requirements. We need to know, how are these going to run on the pipeline? How many environments do we want on this pipeline? Pipeline is just like a long phase. I have tested here. I want to move the same testing to another place. I want to move that same one that I've tested to another place. That is a pipeline. You are all going, putting water in a pipe, going down. That's a pipeline. So in that phase, when those lists are done, of course, you get your environment to be set up, and the developers will give you where you can actually, then at that phase, you are developing your test cases too. All these are working in parallel. You must, when you're doing things, you must prepare down before this test environment comes in, before development is done. You as a tester, you must be prepared. Your preparation is the test case design, your test plan. Like now, when you want to start your sprint one, my expectation for you as a team, as an intern, is that you must all create a test plan and a test strategy. You cannot start a project without that. It's impossible. You must create a document, send it to the wider team, let them all have a transparent feature that this is what testing is going to do. So let's look at the activities of test environment setup. The first one is analyze the requirement and preparing the list of required hardware and software to set up the test environment. This is going to be done by the help of the developer. We've got infrastructure team. If it's a big organization, there are configuration environments team. All this, the development life cycle has different bodies that make things work. Setting up test environment, executing a smoke test on the test environment to validate that readiness and stability of the test environment. Smoke tests. When you are given a test environment that you have been testing on, you want to validate, is it true that this works? Click on the registration. Yes, the registration link is opened. Am I able to register? Quickly register and see, oh, registration successful. If that's a smoke test, when the registration was successful, I tried to log in again. When I tried to log in, I'm able to launch the application. That's a quick smoke test, just to know that yes, the environment is working as expected. What's the next thing? The deliverables of the test environment setup. What are the deliverables? The test environment is ready for test execution phase. So you must check that. Check all your endpoints. Can you access the endpoint? Look, most of the time, let me tell you, what you'll be getting when you're working with developers is that most things work perfectly in developers' environment. Absolutely, 100%. They will tell you it works in their own development. But that is development stage. There are certain configurations for each of the environment. When it is deployed to testing, a lot of people are using the dev environment. So codes might be omitted while development, things might go wrong. So the code set might not be developed, not all might go into it. So it might not work in yours. If you have checked on your own test environment, you are certain. Take a snapshot of the test environment and the thing you are seeing, send it to them that this is the endpoint. Anytime you are raising a bug, anytime you are doing anything, make sure you have a screenshot. Snipping tool will help you. Make sure you are, and when you are taking a picture, take it with the end point. Nobody will lie. That picture will not say, it won't, it won't, it will make people know that yes, this actually failed in that in that environment. But if you tell them, oh, it failed, and you didn't, and someone goes in there and quickly change things and make things work, they'll tell you, show me what you have said. You don't have any proof. And if you don't have proof today, you don't have proof tomorrow. You are not a proper tester. Even if when you finish testing, when it is working as expected, then you tell them, retested in test environment, working as expected, as I have been able to access the application. See below screenshots and put it with the endpoint. Finish. Put it there. That ascertain that you have tested. Even if you come back and the environment is faulty, at 20th of January 2023, I tested in test environment and it is working as expected. Simple. It is written there. The picture can say it all. People won't come to you. Then smoke test results. We need to deliver a smoke test result. What is smoke test result? You've been able to launch it. You need to explain to them, oh, the smoke test went well. Of course, I'm able to launch the browser. They don't expect everything to work when it comes to smoke test. And that is it with that phase. Let's talk about the next one, which is test execution. What is test execution? Don't forget, go back to fundamental test process. Test implementation and execution. Now we are in the execution phase. We have talked about preparing. We want to execute. We have done our expected result. Actual result, I now have the system. I've started executing. That is it. So as you're executing, you are finding bugs. You are sending it to the developers. As they're fixing it, you are retesting the bug. Don't forget, write another 2 words, retesting and regression. What is retesting? Retesting is that you have found a bug. Previously, you have raised it with the developer. It has fixed that the registration bug, you are unable to register when you click the register button, and you have sent it to the developer. When the developer tells you, tester, that bug has been fixed, then you go back to the bug. You will retest it. The way you started, you have entered your first name, last name, click on the submit, then it should work. That is retesting. Once it works, that bug has worked. That is retesting. What is regression? After you have retested, you want to check that every other thing, whatever feature, the system is not broken. Because don't forget that when a bug is fixed, a code is being deployed, anything can happen to whatever is there before. So anything can happen to it. So it might cause it to fail. So you have to check that other functionalities are working as expected. So that's the way it is. So let's go back. What are the test execution activities? 1, execute the test cases. That's your role. The next thing, record the results in the company's test case management tool, if they have one. 2, the next thing, report any defect for any failed test cases. That's your activities. These are things I will say. Then retesting any defect after these have been fixed by the development team. What are the deliverables? Report on any defects that have been raised during the test execution phase. So do your report. There are ways you can put reports clearly, concise, simple. People don't want to see 2,100 documents on reporting. No. Pie chart, graph, things to show them that this is what the phase is. Overall summary of the test case results, that is it. 80% of them have passed. Oh, the 10 didn't go through, is blocked due to this. 5 not run, 5 of them are non-functional, and that is it. Just give analysis. And the last of it all is test cycle closure. What does this entail? Test closure activity. That is where it's coming from fundamental test process. You can see that I'm just going back to what these phases are. The test closure cycle phase involves the analysis and evaluation of the whole testing cycle to work out what worked and what didn't. That is test closure. So and this is what has worked, this is what didn't work. So wherever the failures are, defect clustering, wherever the failures are, you pick it out and you state it in your closure report. So you evaluate the completion criteria, you evaluate on your coverage, the quality, the time, the cost, the software, and also the business objectives. Any bug that is open, severity, or priority, you'll talk about that. So the last of it, after the completion of the test cycle, is test metrics and test closure reports. TCR will be created. What are the test closure activities? What are the activities? Preparation of test closure reports, evaluating the cycle completion based on the coverage, quality, time, costs, all those. Then you prepare a test matrix based on the above, based on all this. So you can do your coverage, the quality, the time, all this, you can put it in place. What are the deliverables? You deliver a test matrix, you deliver a report, of course, TCR will be delivered. That is it. And that ends the life cycle of software testing life cycle. Now, I bring you to another life cycle, which is called the defect life cycle. We have been talking more about defect, bugs. This is how the life cycle is. So defect is just that things that you have found that the bugs that you have found, all the errors there are stages these bugs go through. So we want to talk about the bug life cycle. So when we are talking about the defect life cycle, it also involves the clarification of different priority and severity. Take these two words, priority and severity. I've mentioned all these words, they work hand in hand. They are twins. Verification, validation, actual and expected. You are talking about priority and severity. All these are twin. They work hand in hand. They are interview questions. They will ask you, what is a priority? What is a severity? If they ask you one, they must ask you the meaning of the second one. It's a must because they are twin brother. They are always and they are just opposite. They work hand in hand. They must work together. They are together. So the next thing is talking about defect priority. It refers to the order in which defects should be resolved. The order you want your defect to be resolved is the priority. So if you want the registration defect to be resolved, put it as a 1 because you want it first to be resolved. If you want login to be the next one, put it as 2. Let them know each of the bug that you raised. Put a priority to it. If you have found a bug in registration, you will know that it's more of a critical bug. If people cannot register, they can't use the site. So it's something you have to weigh high. So you have to put a 1, which one starts as the highest. So it's just the order in which the bug is to be resolved. Why severity is the actual how the bug is affecting the application you are testing. So the severity will be, is it a critical bug? If you cannot register, then it means people cannot use the application. It is critical. So your severity will be 1, maybe critical. It will be stated there 1, critical. So that will be your severity. If it is okay, 2. So we as testers, you have to be careful to know what is going to be your SEV 1 and 2. We call it SEV, just a shortening of severity. SEV, S-E-V. So you classify it. It depends on the complexity of the bug. How does it really affect it? If you cannot log in, it is a critical bug. It's a major one. It's high bug. So that's the difference. Priority, severity. Priority is just the order in which you want the defects to be fixed, to be resolved, to be fixed. Resolved is fixed. So while severity is the impact of the defect, where exactly, how is it impacting the application? How is this thing affecting that application? That's the severity. So let's take it. This is a bug life cycle. How does this work? So when you raise a bug, you start from here. New is the bug. I have raised a bug now on my bug. My bug title is unable to access Blue Sky login page. That's my bug title. I put a step to reproduce. Given I go into the URL, I had my login details, valid login details. Unfortunately, I'm able to read. So at this phase, nothing has been happened. We now call ourselves, there's a defect triage session where the developer is there, you as a tester, and also maybe the project manager, the scrum master, they are also involved when it comes to defect, and also the business. It depends on the complexity of the application or the system you're actually working on. That's the new state. At the new state, we all as a team will decide with them, okay, do we want to reject? No. If people cannot log in, we cannot reject it. So hence, this one cannot go. We now move it. From there, it goes to open. So we open we change the status from new to open. After new, it gets, once it's open, it's picked up by the developer. So it's going to be, when it's opened, we assign it. It's been assigned to a developer, the person that is going to fix it. So it gets fixed. Once it's fixed, it's retested. You can see now where the word retesting comes in. Once it's retested, are you happy? Is the bug really retested? Is it fixed? If yes, you close the bug. If no, you reopen the bug and you go through the life cycle again. Go back, and once you reopen it, someone will pick it again and fix it. We go into the loop, we retest it. If it's done, then you close it. That's it. At this stage, let me go back. If it is a new bug and it's opened, if they look at it, do we really want to fix this in this sprint? No, we can defer it. So we keep the bug, it will be there. But you change the word to defer. So you can put it in the next sprint if they're going to fix it. That is the total view of a defect life cycle. Now, the new, you have raised, it has been raised, and it's not been validated yet. The next one is open, which is a member of the development team is going to be assigned to the person. The next one is going to be active. These are the states. Is going to be active. This defect is now being investigated by the development team. The next activity is test. The defect has been fixed and now is ready for QA team to verify. Now is reopened. We as QA, we have rejected it. There's still an issue. Please, can you refix it? They will go into it. And when you reopen a defect, please ensure you put relevant screenshots and explanation of the reason why you're reopening it. The next thing is verified. The defect has been verified and fixed by the QA. Then the next thing is that you close it. So it no longer exists. So if it's rejected, you will know that yes, if it's rejected, you have to write the reason why it's rejected. Sometimes bugs might be duplicated, so you can write it duplicated. Put the bug number that is linked to it. If it's rejected because we can't fix it, it's not a bug, fine, put it there. Then if it's deferred, put the reason, and it's going to be prioritized in the next release. That's the way it is. So that's the whole state of it. Now, defect priorities. I just took it so that I've explained to you what it is. So you as a tester, as a QA team, as a software tester, as a UAT tester, anything to do with testing, as young agile tester, you as an agile tester, your priority here is to state the priority for each of the bug or the defect you have raised. So when you state the priority, in priority, there are ways you can say there's a low priority. What is low? Maybe color is the difference. We want it blue, we don't want it yellow. Minor fixes, things that are not urgent, things that is just a nice to have. It doesn't spoil the application. If it's there, it's fine. If I wanted this background to be white or yellow, yeah, but is it still doing what exactly I want it to? Yeah, of course, people can see it. So that's a low. The next one we have is a medium priority. Development team should fix the bug in subsequent builds. So medium, we have to fix it, but we can still do away with it. Not as much as this low one. This low one, we can just leave it, and even if we bring out our TCR, it's no issue as long as it. Then the next one is I. This one is compulsory. It must be fixed. The impact of the bug on the software is substantial and should be addressed immediately. Immediately. Urgent. It is a must. We cannot do anything if this defect is not fixed. If you cannot launch an application, you can't work. So the defect has to be fixed. So don't forget, I'll go back again. For defect priorities, low, medium, high, urgent. That's it. So let's go to severity. The severity of this is based on how severely the defect impacts the functionality of the software and how complex it is for development team to resolve. Severity is always used all the time. So let's start with the critical one. The critical one, it means is a core one. We cannot do it. This really affects the application. So an example would be let's take an example that you want to log in. You have put your valid details. You've checked everything. You have the right endpoint. You are in the right environment. You cannot log in. And you are told to test. How will you test? You can't, as long as you can't access the environment. So it is a critical, it's a blocker. So you can't. It has to be fixed. The next one is a major one. Major one is just like you talking about. We also need to test this. We need to test it. It's more like the same thing with the first one. It's also is a major defect. We need to test it. The next one we talk about is medium. Medium, of course, we can still manage without this, and that's a medium. And the next one is low, and low is more of, it could be maybe something we can fix later, we can have a way with it. So that's the way it is. What is the difference between both of them? I've just put the both of them. What are the differences? The differences are these. Sdlc, is development life cycle. The other one is testing life cycle. The main one is Sdlc life cycle is to complete successful development of the software, including testing and other phases. But for Stlc, the only objective is for testing, is a testing phase. It's just you as a tester that is involved. In Sdlc, the business analyst gathers the requirements and creates document plan. While in Stlc, it's you as the tester that does the analysis, the requirement, the document, functional and not, is created by you. It's your testing document. In Sdlc, the development team creates high and low level design plan. In Stlc, the tester creates the integration testing plan. That's you are the one to create the test plan. The real code is deployed, is deployed, and actual work takes place as per the design document. But here, the testing team prepares the environment and executes them. Sdlc phases also include post-deployment supports and updates, where testers execute regression test suites, usually automation scripts to check maintenance code deployment. So I just bring it to you to just see that. I put it in a V model just for you to see that this side you can say Sdlc and here you can say Stlc. That's just the way to identify it. And I'd like to say thank you all for tonight and Q&A time. So I don't know if you've been putting questions in.